So Markus, I think it's time for your presentation now.
Yeah, hello. Hello, thanks everybody. So try to share my screen. I hope things work like they did in the test. So open the presentation, have it on.
It's perfect now.
Yeah, so my name is Markus Riedi, I'm the CEO of Opto, and today I want to share you a little bit about our new technologies around Solino. So you always heard about different things about visualization, and I asked the question, what are the biggest concerns when implementing artificial or deep learning solutions? So, and our task today from Opto is lack of trust in the process. So we are wanting to give a little bit bigger impact in this topic here today. What are we doing? We are building, so to say, this plug and play microscopes, digital microscopes. So we are really focusing on things that you principally can't see, where you need special technologies. We are going down to the microns or even nanometers. And the products that we are showing, so are digital microscopes, imaging modules, or modules that are doing applications that we call job modules. And as you might know, microscopy is very much for medtech, but also for industry. What is an imaging module? It consists of a camera, it consists of cables. So we're doing our optics since more than 40 years. We're doing our controllers. And then the idea, like with the iPhone, is to have several models, mechanically equip them with some software, and then you can go to different applications. So it's plug and play. It's easy to use for one application, one product. The same modularity with the imaging modules is the same modularity in the software, and out of this we can create for you very, very specific niche products. We call these plugins. Like with the phone, you have apps and an app doing an application, or we're doing really customized product. So I hope you see nothing. That's the topic of today. What you can't see, not even artificial intelligence can classify or can really detect. So it's about this really forming and giving a little bit more trust in the robustness of such artificial or deep learning solutions. So here it's with a different light, but if you see this, okay, and want to detect the writing, you will have really problems in having it from this side. The same here, so you want to detect things that can't be seen must be made visible. Otherwise, no solution can be done, and therefore we have imaging modules. There we have different solutions to apply to the different locations to really have one perfect image, one reliable and repeatable every time, everywhere. If you have a production line somewhere in Asia or somewhere in Europe, it should work the same without changing configurations. So we are really taking care that each module is delivered for one application in the same way to all parts of the world. So one module for one application. So different form factors, that's it. So ask us. So normally for each application, we want to build really one product, one solution. What makes deep learning really sensible? So where make it sense when we are speaking really about microscopy things, also where conventional techniques not work. So we have this thing called phase contrast, for example, in microscopy. So we have these things where one product, like Inspector is saying, one imaging setup should be used for many applications, different defects or very complex things. So for example, when you're speaking about deep learning and artificial intelligence in microscopy, so cancer research, pathology is a big thing that we are talking here about, in the way that it's a very complex image, and the detection if you have cancer or not is quite complex. Again, now Solino is, so say, a technology where we are really focusing on extracting particular images, extracting particular features out of the image setup, and now I want to tell you a little bit how we can go there. So one reliable image, what you can't see, to detect more specific anomalies, that's the type of way we are going here. And we call it here data cleaning. And if you see images like this, you can say, okay, yeah, it's quite difficult for each AI and so on to select the different people because the main features are the same. If they are cleaned, it should be quite easy to say, okay, this is the one and this the other. That's principally the way about how Solino is doing the things, and that's what's the topic of today. So cleaning the image about the results. This is a traditional application out of the forensics. So you have bullets, so that's a normal image that you can get with an imaging modules. But if you want to get more, okay, you want to clean, you want to extract some features into an image. That's the really first step. So I'm not speaking about artificial intelligence. I'm speaking about feeding the artificial intelligence, the deep learning algorithms with reliable data, always at the same time, and really having, so to say, insights. And here you can very simple say, okay, yeah, the bullet was penetrated in this one, this cartridge, or in another way. Why more reliable image data with Solino? How are we doing this? So we are using here, so to say, photometric stereo approach. So we have 64 LEDs in a dome light. And this is a technical reason why we're using these angles. So principally we are illuminating from one angle that, or from each angle that can apply to get reflections out of it. So we're not concentrating on the image alone, we concentrate also on the reflections that are coming back. So it's not something like called shade from shading technology, it's really analyzing the stray response. And that's principally the product that we showed here first time. And another aspect that we are really going for is predictive maintenance to really digitalize the visual appearance of objects. What are you doing? So you're trying to tilt your product to identify glossy defects, dull, clear, and shininess. And that's what we showed now first time ever. So development time was about 10 years now to bring it to these markets. So we are in charge of the algorithms, we are in charge of the product. So we're doing everything in-house. And the idea is, so to say, you have a product, you make these 64 images, and then you apply different Solino algorithms that you can also afterwards pre-process in really showing the anomalies and the defects in an image. So the software is analyzing, so to say, the images, the 64 images, is focusing on an anomaly, and then you can show it on one image. So on another way, if you have the image, and if you want to go one step further, and going for predictive maintenance or quality control. So, and we are talking here about products that are not, so to say, simple. If you have a very clean product, and normally the products are very nice and very good. If you have a very small dent or here and there, that's what we are focusing on. And we want to make it visible, and Solino is a technology that normally can really digitalize the whole performance of the product. Color, shape, hue, everything in one image. So the difference to a traditional artificial intelligence solution is you're working in a traditional setup or imaging setup, or even if it's an image processing setup with one image made with one specific device. And then you put it in neural networks, you are calibrating it and making the modeling and the analysis. And what we are doing, so to say, in the first level is saying, okay, we deliver clear images. We give the trust in the image, as we are making 64 images, not only one, and we are processing the images. We are processing it always the same way to highlight really the anomaly. So in the data, we have all the informations based on the 64 images, and then we also selecting the images. And now you can very traditionally or very easily see if you're feeding a neural network or then an AI solution with the image on the top or an image on the bottom, it will make a difference. Will make absolutely a difference, even for the AI, for the guys who are training the neural network, because you have really highlighted the information. And these images that we are getting, and this is the module that we are delivering, that what we call CPI images, computation of particular images. So we take these images and we are extracting the highlights of the image. So that's what we are focusing now. That's where we are today. That's really for purchase. That's really for demos. Ask us for your samples. So we are really at the beginning here after 10 years of development. So it's stable, it works. So many R&D went through it, and it's part of our imaging module family. So like microscopes, we have this imaging module now done. We're focusing on a field of view about 10 to 12 millimeters at that moment, as we are in the micron level, as we are coming out of the microscopy. But nevertheless, like the question before, we are in charge of the technology. We are the owners of the technology, so we can apply it to different applications. So even ask us for a project where the technology should be applied to. And now giving you a little bit an outlook where this technology can go and what you can do principally with it is saying, so say we are touching with these image-based things the tip of the iceberg virtually. So one side we have the image, it should be much better with this computational imaging, with these Solino CPI images, but nevertheless, if you are under the radar here and extracting that what's not really visible, we try to make it here a little bit different. As the information that we are gathering with all our algorithms and all our images that we have, we can, in addition to the image and showing the anomalies in an image, we even can extract or working on extracting in particular features. So if you are recognizing these different spots are different anomalies of your product. So if you are transferring these images into data, into the data space, Solino is enabling you to principally sort the anomalies or sort the defects in different data packages. And these are the data packages. And now it's a different way about how to work with these data packages, to really extract these particular features and then sort it. And then, so to say, Solino is really enabling or has the possibility to deliver you immediately the anomaly out of your product. A different in shape, a different in height, a different in color. And then it's pure the learning and pure the application that you're going for. So we can principally, Solino can principally extract particular features. That's what we are not offering at the moment. That's really project business. So we are searching here for partners helping us, but it's a dramatic change principally in protective maintenance. That's what we can go for. Yes, indeed, at the moment, a small field of use, but the technology can be applied to different models. And then this step from having, so to say, these traditional AI deep learning applications with particular images, we can go a different way and going directly to prediction and directly to predictive maintenance with a very robust and trustable thing, as we can extract then the features that the AI or that our prediction mentioned. We can show also as an image, so the trust in the process, the trust in the thing is, so to say, the extracted image at the end. Yeah, so we are searching for partners for these niche markets to bring Solino to the next level. So we showed this at the first shows. So contact us with samples, contact us with projects where you think that can be applied to. That's what we want. So in a summary here, a small video to show you some applications that we have done in the past. So AI-ready sensors, that's what all our imaging modules are. The photometric stereo is the background. We are creating these images out of 64 images. The type of processing is RTI, reflective transfer imaging, that's in the background. And these are principally the results. So we can detect anomalies in a later thing, but for quality inspection or for predictive maintenance, I think this visualization of standard imaging and solino imaging shows you what the potential is behind the scenario. And when you see these images, you should say, okay, yes, now I can really also trust the image, because this is all time there. We have 64 light conditions, so principally every stray light effect is eliminated by the algorithms, and then it's purely a project or your application that is defining is it working or is it not working at that moment, only in a small field of view, as we are the microscopic specialists. Yeah, that's it in a nutshell. So I hope you liked the presentation. So please feel free to ask several questions. Thanks to the audience, thanks to Peter to give us the time for showing this results here. And yeah, thanks.
I think we need some more time until you answered all the questions I see here. How much time Solino needs to process the 64 images during runtime application?
So we are at that moment, so to say, with a very simple, basic computer setup, about some seconds. So we are speaking here about 5 or 10 seconds. But a normal process, when we are speaking about process time, we can reduce the 64 to maybe 6 or 10 lights to highlight the anomaly that you're searching for. If you want this holistic thing, then we're speaking about some second, and then it's pure processing time, and the computer to speed it up to maybe a second or two. But that's what we need. And we have more than 200 algorithms in the background, so running all through this makes no really big sense here. So if you focus only on one, it's one processing, and then it's in seconds. But at that moment, we are really targeting those standalone units. Forensics is, so we have very unique applications running, and it's very early for us also. So ask me maybe in a year how fast we can do it.
Evergreen question in the field of visual inspection. Is Solino or another optosensor able to recognize little small scratches in the glass door bullseye of a washing machine?
Principally, yes. Yeah, it can do so, but we are speaking here about 10 by 12 millimeters. So you saw that the working distance is very small. So if you can lie at the washing machine and put the sensor on top, yes, indeed, you can see a small scratch, but a scratch of 800 nanometers on a washing machine, I think it's not in the criteria catalog of Miele.
We at Inspector, we had some several use cases that we saw.
I think that's absolutely more the use case for Inspector. So for us, it's the microscopy at that time. So it's more the complexity. It's a different way.
I think we can start with our final Q&A. So Offer and Joseph, maybe you can start your cameras once again. So hi. But there's still a question for Markus. Don't you think some anomalies are more visible in some of the 64 images than in the aggregated CPI image? Feeding deep learning models the stack of 64 images and letting it decide what to use in the 64 images might be more efficient as all the information is present. Did you investigate this?
Yes, absolutely. So, but we are not using the single images out of the 64. We are extracting out of each image automatically of the 64 the anomalies, and we put them in an algorithm together and in one data. And now we extract in the CPI images the images that you want. But every, so to say, defect, every anomaly is stored in the data. You only have then algorithms to show you. That's so to say, if you saw the faces, if you want to only look at the noses, okay, CPI images only show you the noses.
There is another question to this point. stated otherwise, can we have access to the 64 images instead of the aggregated CPI image?
Yes, indeed, that's what you want. So they are available. So we are offering this as Inspector also as a plug-and-play system. So it's coming with the software. But yes, indeed. So we are the producer of these things, and then it's purely about business case.
A question for Markus. Are there different illumination colors or only white light?
At the moment, only white light, but that's when there's a big application, yes, indeed. So we can use different monochromatic light.
And there's a question, what is the main difference of Solino to other techniques like photometric stereo, for example?
Photometric stereo is principally the way about how to merge the image in a standard algorithm of different angles. We are analyzing the stray response. So we are really going about reflections. So the quality of image should not be nice. So one image has a big reflection, but when we know where it is, we can recalibrate and we know exactly what effect it has for the anomaly. So it's a different way about going. So it's nothing to do with photometric stereo.
Now I have a question. Is Solino a product or a technology?
Virtually both. So it started really as a technology. We tried to sell it as a technology with partners, but now we have a product.
Great. So see you, stay healthy, and bye.